Last episode covered writing tests and table-driven patterns, the foundation. This episode goes further, measuring performance with benchmarks, understanding what's tested with coverage, isolating dependencies with mocks, and the habits that separate good test suites from fragile ones. These are the tools you'll use every day in production Go code. A benchmark function follows the same naming convention as a test. It lives in a test.go file, starts with benchmark, and takes a testing.b instead of testing.t. That's all the declaration you need. The body of a benchmark contains exactly one loop, for I equals 0, I less than b.n, I++. The code you want to measure goes inside that loop. b.n is not a constant you set. It's controlled by the testing framework. The framework runs your benchmark repeatedly, increasing b.n each time, until the timer has accumulated enough data to produce a stable nanoseconds per operation figure. You don't run benchmarks with plain Go test. That command runs only test and example functions. To run benchmarks, you need the bench flag, go test bench equals. Runs all benchmarks in the package. Go test bench equals benchmark add runs only that one. The .in bench equals is a regex matching everything. Benchmem adds memory profiling to the output. You'll see two extra columns. Bytes allocated per operation and allocations per operation. These matter because each heap allocation has a cost, both the allocation itself and the pressure it puts on the garbage collector. The output of a benchmark has a fixed format. Take benchmark add 8100000000.3149 nanoseconds per op. The -8 suffix is GOMAXPROCS, the number of OS threads Go used. 10000000000 is the final BN. 0.3149 nanoseconds per op is the number you care about. Nanoseconds per operation. For comparison, a nanosecond is a billionth of a second. Modern CPUs run at 3 GHz, so a single clock cycle is about 0.3 nanoseconds. That add benchmark is telling you the function executes in roughly 1 clock cycle. It's essentially free. The string concatenation example is a classic benchmark in Go. S plus equals a creates a new string on each iteration because strings are immutable. Strings. Builder grows a byte buffer in place and only allocates once when you call string. The benchmark with benchmem makes this visible. Concat shows thousands of bytes per operation and 1 allocation per iteration. Builder shows 0 allocations. That's the kind of insight benchmarks are for. If your benchmark has expensive setup, loading a file, generating data, creating a struct, that setup time inflates the per operation number. B.reset timer zeros the clock. Call it immediately after setup completes and before the timing loop. The framework ignores everything before the reset. Subbenchmarks with b.run let you compare multiple variants in one function. If you want to know how sort performance scales with input size, you write one benchmark sort function, loop over sizes 100, 1000, 10,000, and call b.run for each. The output labels each variant with its name, so you can see the scaling at a glance. b.reportallocs does the same thing as benchmem but from inside the function. Useful when you want memory stats for a specific benchmark without affecting others. Example functions serve double duty. They're tests that verify output, and their documentation that appears in GoDoc and on package go.dev. The naming convention is example followed by the function name, example add. The key feature is the // output, comment at the end. The testing framework captures stout from the function, compares it to the comment, and fails if they don't match. If you change the function's behavior and forget to update the example, GoTest catches it. Multiple examples for the same function use a suffix. Example divided by 0. The suffix appears in the documentation alongside the main example, so readers see multiple use cases without opening the source. If you omit the // output comment, the example still compiles and runs, it just doesn't check the output. Useful for examples that print non-deterministic output like maps. Coverage tells you which lines of code your tests actually execute. Go test cover prints a percentage per package at the end of the run. That's useful for a quick sanity check, but the real value is the HTML report. Go test cover profile equals cov.out writes coverage data to a file. Go tool cover HTML equals cov.out opens a browser showing every file with executed lines in green and unexecuted lines in red. This is how you find the error branch you forgot to test, or the edge case that's never triggered in your test suite. A common misconception: 100% coverage means the tests are complete. It doesn't. Coverage measures which lines execute, not whether the assertions are correct, not whether all input combinations are covered, not whether concurrent behavior is safe. High coverage is necessary but not sufficient. Use it to find gaps, not to declare victory. Cover mode equals atomic is the right choice when benchmarking coverage in code that uses goroutines. It uses atomic operations to count hits safely. The default set mode only checks whether a line was hit at all. Count mode tracks how many times. Mocking in Go is interface-based. The key insight is that Go's implicit interfaces mean you don't need a mock framework, a shared interface package, or any build-time code generation. You define an interface that describes what your code needs from a dependency, and you write a struct that implements it. The production code uses the real implementation. The test code uses the mock. The user repository interface has two methods: getUser and saveUser. The user service takes a user repository in its constructor, not a database connection, not a concrete type. In production, you pass a real DB implementation. In tests, you pass a mock user repo. The mock is just a struct. It holds a map of preceded data and optional error fields. Helper methods setUser and setGetError let each test configure exactly what the mock returns. No global state. No shared setup. Each test creates its own mock and configures it independently. This design has a name: dependency injection. You inject the dependency through the constructor rather than creating it inside the function. It's not a pattern specific to testing. It's how you make any code composable and replaceable. With the mock in hand, tests become straightforward. Seed data with setUser, call the service method, check the result. Configure an error with setGetError, call again. Verify the error is returned. These tests run in microseconds. No database to start. No network to wait on. No test data to clean up. They're deterministic. Every run produces the same result. And they're isolated. A failure in one test doesn't pollute the state for the next. The other benefit: you can test error conditions that are hard to trigger against a real database. You can't easily make a real database return a connection timeout on demand. You can configure a mock to return that error with one line. Keep mocks simple. Only implement the interface methods you actually use. Don't add features to the mock that the tests don't need. It's extra complexity that makes the test harder to read. The rules that make test suites maintainable: test behavior, not implementation. Your tests should verify what the function does, not how it does it internally. If a test breaks when you rename an internal variable, the test is testing the wrong thing. Write tests alongside code. Tests written after the fact are harder. You're working with code you didn't design for testability. Tests written while you write the code catch design problems early. Make failures useful. T.errorf, got%d, want%d, got, want, is a useful failure. T.error, assertion failed, is not. When a CI build fails at 2 a.m., the error message is all you have. Fast tests are more valuable than slow tests. If your test suite takes 10 minutes to run, developers stop running it locally. Tests that require a live database, a real HTTP server, or actual sleep calls slow the suite. Mock external dependencies. Test integrations separately and less frequently. Don't test things that are already tested. If you call JSON Marshall, you don't need to test that JSON. Marshall works, the standard library has its own tests. Test your code's behavior, not the libraries. Benchmarks. Benchmark functions with b.n loops. Bench equals. To run, b.reset timer for setup, benchmem for allocations. Read ns/op, b/op, allocs/op examples. Example functions with // output. Comments, they test and document simultaneously. Coverage, cover for quick percentage, cover profile plus go tool cover, HTML for visual gaps. Mocking. Interfaces enable swappable dependencies. Handwritten mocks are simple and effective. Best practices. Test behavior right alongside code. Make failures useful, keep tests fast. Next episode, Reflection and the Reflect package, goes runtime type introspection. This course is based on the complete guide to Go programming. Available on Apple Books and Amazon. Find it at pixelstech.net/book. See you in episode 22.